R is the radius. Anjayamma video talli. Which angle this one is? Shear angle. That is the shear angle. This is what? Arc length we will take. I think somewhere it gone wrong. This is what angle of twist, theta we have taken. And we have said that yesterday, this arc length is same for this bigger arc and then this smaller arc. This sector is there, bigger sector and then smaller sector. Let me take this is O and this is, let me take a point twist now, so that I will take it as T. So that for the OP and then P dash sector and then for the TPP dash sector. P dash is same only for both. Arc length is same only. So arc length is equals theta is equals to what is the formula for us? Angle is equals to what is the formula? Arc length by radius we have to take. So that here the radius of the bigger sector is how much? Nothing but L. Obviously the length of the cylindrical wire is how much? L only here. Dhanush, be in the class. ಯಾರನ್ನ ನೋಡಿ ಬಂದಿದೆ ಮನೆಯಲ್ಲಿ ಇಲ್ಲ ಅಲ್ಲ ಯಾರು ನೆನಪು ಬರ್ತಾ ಇದ್ರಾ? It's okay, you can go after some days. So here I have taken the bigger sector and then smaller sector. For both the sectors, arc length is how much? Nothing but that is P dash only. Now whenever you see the bigger sector like this is P and then P dash and then O and then this one is what? Angle of shear. And then smaller sector if you consider, that is very small, that is P dash again. Here angle is how much? Theta. The radius of the circle is how much? R here. Now these are the two sectors are there, but for both what I am saying nothing but P dash is same only. Whenever I said the arc length is same, arc length is equals to what is the formula? Angle into the radius. So arc length P dash is equals to here. Angle is how much here? Angle is shear angle is phi. Radius is how much? Total length of the cylinder is how much? L. So that is L. Then in this case, the arc length P dash is equals to angle is how much here? Theta angle of twist and then radius is R. Whenever you see both the arc lengths are same here, P dash and then P dash, then what we can say nothing but theta R is equals to pi into L, then theta angle of twist is equals to phi L by R. This is the formula for the angle of twist. And in this you can observe that clearly. So I have taken this one as the cylindrical wire. This one as a cylindrical wire I have considered, and then for that what I am doing nothing but I am applying some torque here. By applying some torque, then what I can do? I can rotate this one. So I will show you in the bottom end also. A chair ಚೆನ್ನಾಗಿ ಹಾಕಪ್ಪ. So first of all, so whenever we are twisting this one, I am applying some force I am applying some torque to rotate it. So that I am applying some torque and then rotating here. Then what happening? Line is moving or not? Line is moving. Initially where it was like straight line. Initial line also you have to remember. Finally it is displacing by how much angle? Nothing but phi is the angle. So tangential it is displacing nothing but which modulus is there? Tangential modulus, otherwise shear modulus is there. So tangential force and then it is moving, it is displacing nothing but at that time shear modulus will come. Why? Because initially there was a straight line like this. Now whenever I rotate, at that time it is bending. It is just slantly, it is coming like this. This is a line we got finally. So for that line, what is the angle? Nothing but angle of shear will come. And also whenever you see observe the bottom end, at that time this is the initial line for us. Now what I am doing nothing but I am rotating it. So initially it was straight. And after that what happening? It is becoming slant, so that how much ever this line displaced, how much ever this vertical line displays, that much only this also displaced. See that whenever you see this is the point of contact of them, then what happening, nothing but both are having same displacement, by the way. Same displacement, nothing but same arc length they are having. The arc length is same like this. So whenever you observe this one, initially it was there like this, then finally it is coming here. So let us observe. Yes sir, both was there initially at this point only, and finally both are coming to this point only. So that can I say that they made the same arc length here? Arc length is same. Arc length is same only, so that P dash we got. That P dash is same for the bigger line and then for the smaller line also. For the bigger line, what is the angle we got? Nothing but shear angle phi, and then for the smaller one, what we got? Nothing but angle of twist theta. And now arc length is same for both. Now this is the bigger cylinder we got. For that radius, this is the bigger arc from here to here we got like this. So for that bigger arc, what is the radius? Nothing but that is the length of the cylinder only L. And then for the smaller arc, what is the length here? Obviously radius R only, right? Radius small r only. So that is what we have taken, that is P dash and then P dash, both are same for both the arcs whatever we got here. And then angle of twist theta is equal to how much you will get? Pi L by R. That is pi nothing but what? Angle of shear. L is nothing but length of the cylindrical wire. R is nothing but what? Radius of the cylinder. Clear, right? Theta is equals to phi L by R. This is what we have discussed yesterday. And still we will still discuss some more things in this. That is, we are applying, I said we are applying what to rotate. Whenever you are rotating something, nothing but you have to apply what? Torque only. What is the torque formula for us? Force into perpendicular distance. And also, this is a massive string or massless string? Rod I have taken, cylindrical rod. Cylindrical rod nothing but it is having some mass. So mass is there, nothing but where the weight will act? Center of gravity. You forget about the work energy theorem, work energy power. In work power energy, whenever we have taken the massive chain on the table, at that time where we have applied the weight, weight is acting at the center of gravity, exactly center of gravity. So for this, where the center of gravity is there, nothing but here the center of gravity is there. So here mg is acting at what distance? L by 2 distance. So that L by 2 you have to take, and then you have to find out the torque. One more will be there, we call it as shear rigidity, otherwise torsional rigidity. See that here, this one is, what I said, this one is torsional pendulum I said. In the SHM also you will get the same thing, then we will call it as torsional pendulum like that. So whenever you are twisting nothing but at that time, there is a torsion we are producing in that we call as what? Torsional rigidity. Nothing but this is also one of the constant only, torsional rigidity. Torsional rigidity. That will be denoted by C. What is the torsional rigidity? Nothing but the torque we are providing divided by the angle which we are twisting. Nothing but the ratio of the torque to the angle of twist is known as the torque rigidity. This is also constant only. Whenever you see stress is nothing but what we have taken? Force by area. In the same way, here torque nothing but what is the formula we will get? Force into perpendicular distance. Force into perpendicular distance, that is F into L divided by what is the theta we will get? Angle of twist is how much? Phi L by L we will get. So by that what we will get? Nothing but here torsional rigidity we got it as. So that is a constant of a torsional pendulum, otherwise torsional rod, that is C is equals to what we will get? The unit angular torque divided by the unit angular twist. So that d tau by d theta we will get. From this, I want to get the C value. To get the C value, what we can do? D tau nothing but what? Torque. Torque, what is the formula? Force into perpendicular distance. So that force into perpendicular distance here, that divided by d theta nothing but what? Angle of twist is what? Theta is equals to phi L by R. So here phi L divided by R. Then what we can cancel here? L gets cancelled. Then what is remaining? Fr by phi. So F nothing but what? Force. Which force is acting on this? Gravitational force only, right? mg. And then radius of the circular plate is circular area is how much? R only. And phi is nothing but what here? Shear angle. So that here mg into radius is R only. That divided by shear angle formula is what? Phi is equals to what is the formula? X divided by L. So that X divided by L you have to take. And also where this force is acting, exactly at what distance? L by 2 distance. So that x divided by L by 2 distance. Then what will you get here? Nothing but mg into r by, what will you get here? 2 into x. This is the C we will get. mg/rl kada? Yes, mg/rl. mg/rl by 2 into x. That is the rigidity of torsional. So torsional rigidity. Whenever you are taking the torque, in this most of all this only important. Angle of twist is theta is equals to phi L by r. After that you want to get the torsional rigidity, nothing but what is the torsional rigidity? The ratio of the torque provided divided by the angle of twist. So that C is equals to d tau by d theta I have taken. Torque nothing but what is the formula for us? Force into perpendicular distance, and also force into perpendicular distance nothing but we are providing the torque here. What is the perpendicular distance for that? R only, right? See the bottom surface if you see that. Okay? Camera failed.